Okay, welcome everybody. Thank you so much for attending. We appreciate everyone who's joined. My name is Rob Ketcher. I'm with Google. Today, we're going to be talking about CBRS and just a couple logistic points here. We are recording the webinar and we'll post this after we're done. For questions, if any of you have questions, there's a Q&A button. Just feel free to click on that and send that in. You can send them in live while we're doing the slides and doing our presentation. We may pick some during the presentation. We'll likely hold most question and answer for the end. But if there's something really relevant, we'll try and address it straight away. And without further ado, well, actually, maybe just a quick intro of who else is here with me for the presentation. Matt, you want to say hello and introduce yourself?
Hi, everyone. Matt Varghese. I lead product for the wireless services team. It's unfortunate that we weren't able to do all of this live, but I'm excited to show you the progress that we've made.
So let's go ahead and get started. So I do like to set context for everybody about why is Google in CBRS, why do we care about CBRS? If you think about our products, Google's products run on the internet. Our customers access those products. To access those products, they need good, high quality internet connection. So it makes sense that we care about that. And that's what our group is chartered to do here at Google. We're chartered to create what we call wireless abundance. Which many of you heard me say in the past. It's a fancy way of saying better internet for more people in more places. You guys are on the front lines making that happen, which is important, even more important now as so many people are at home and relying on the internet for essentials. Okay, so CBRS went live at the end of January. We are now in what's called the full commercial phase of CBRS. As you can see, adoption has been strong. The growth rate has just really been phenomenal. We've been blown away by it. We actually thought that with COVID things might slow down a touch, but if anything, it's been accelerating. I just want to give you an overview of the technology that we have for CBRS. So the first product that we have is a spectrum access system that controls fundamental access to CBRS spectrum. We have a network planner, which is like powerful network planning right in your browser. We also offer CPI training, which makes it really easy for you to get up and running to install CBRS devices. Now, something that's unique about CBRS is that your network now depends on a cloud service. So if your CBSD loses a connection with the SaaS, that CBSD needs to turn down. And that means your network comes down. Google knows how to operate large-scale systems reliably. We now have 8 products with over 1 billion monthly active users. And we're bringing that same level of reliability to your networks and your customers. Google also has a really unique set of assets for the CBRS ecosystem. When you're a spectrum access system and you need to maximize spectrum availability or maximize and you need to model propagation, you need 3 key ingredients to get the right answer and get it quickly. And that's data, propagation, and compute. So Google brings its nationwide high resolution data, a really unique asset. We've taken a best of breed propagation engine. So you need the right algorithm, put that into the cloud, and it can scale up massively and run things in parallel and get you the right answer and get it fast. Now, you guys are already familiar with geodata through products like Earth and Maps and Satellite View and Street View. And what I want to do is take you a little bit deeper into understanding how that data is generated and what it means for you, especially for you who are out in more rural parts of the country, and how we're bringing the best of Google to you. So first, how do we get this data? So Google collects a massive amount of images. We're actually flying planes all over the country. They fly at different altitudes. We're driving cars. And all these high-res images come back to Google We then run them through a data pipeline where we first extract out using machine learning-based image recognition algorithms. We're able to extract out and identify what's a tree, what's a building. We then take that data and transform it even further, where we're modeling real-world characteristics. So this would be things like heights of trees, slopes of roofs, mapping addresses to lat longs. And when it comes to collection of data, Google has high-res coverage, high-res images for 99% of the population. So true nationwide coverage, including in rural areas. Now, when those images come back to Google, they can run through one of two data pipelines. If you've ever been in Google Earth and you've panned around and you see really like the fine detail of trees, heights, you might see a stadium and the way it slopes, stadium seats, like in the image on screen. That's our premium data pipeline. And with that, you're going to get the most accurate 3D view of the world. Now, we also have a basic pipeline, and that's if you've ever been into Google Earth and you see that things are a little bit flatter. That's the basic pipeline. It's still great data, but it's not as detailed as what we know we can deliver. Now, to give you a sense for coverage, where we were a little over 6 months ago in Q4 of 2019, we had 4% coverage, 4% land coverage for our premium data. Now, that was primarily in denser areas. It covered a majority of the population, so a lot of people, but not a lot of land. And we know that a lot of you operate in areas where there's more land than people. So we wanted to bring that same high quality data to you. So where are we today? Today we're at over 60% coverage. We've been investing literally millions of dollars to bring your areas that you serve better high quality data. And to give you a sense, the kind of the premium pipeline that gets you that more detailed 3D view of the world, it's 16 times more computationally intensive. So it's a very, very intensive compute. And we're going to continue rolling that even further. And we expect full coverage, 99% plus of landmass. And we'll expect that by Q4 of 2020. And just so you guys understand, if you go into Google Earth, you still might see an area that looks flat. But actually, when you go to the network planner, we'll have even a higher 3D view of the world in those areas. So we're actually a little bit ahead of Google Earth. They're not necessarily parallel one-to-one, but we are taking that same data and processing it more intensively. Okay, we're now going to jump into a bunch of new features. That's what we've been doing on the data side. Want to show you also what we've been doing on the feature side. And with that, I'm going to turn things over to my colleague, Matt.
Thank you. I'm about to share my screen, so hopefully you'll see something. And just to add to what Rob has said, we've been hard at work trying to improve the geodata that we use in the network planner. The geodata uses the same underlying imagery as Google Earth and our other geo assets, but we have a separate pipeline that extracts data specifically for use in network planner, and our propagation engine uses that data. So even though you may not see 3D in the Google Earth view in network planner, the underlying data is all 3D. Let me start with one of the features that we're introducing, which is in CBRS. Unlike many other bands, the number of channels available in a particular area is very much a function of the number of incumbents in that area. And this can be confusing at times because you don't know how many channels you'll have, and it varies spatially. And so we've spent a lot of effort doing a lot of compute using the SAS engine to determine at a kilometer level resolution how many channels you could expect to get. And we created a heat map in the network planner where you can go out on the left here, you see under overlays, there's a spectrum availability heat map. We have it for Cat Bs, which is what most of you are primarily interested in, but there's a Cat A as well. And with this heat map, you know, there's a description on the right, but it tells you in this particular area, there are, let's see, there's 15 Cat A channels at full power and 10 Cat B channels at full power. And if you go, you can tell exactly what the power is that's available in a particular spot. And so if you go into this area in Louisiana, it will tell you that no channels available at that particular location along the coast. But in Cat A, you still have channels available. This is a pretty powerful heat map, and it varies from place to place. Some areas, like in Mississippi, you don't have to worry too much, all the channels available. But some areas, as you see in Texas, specific channels may not be available because in this particular case, it looks like there are WISPs operating in the area that have Part 90 licenses. These things will change over time, and this heat map will change over time to reflect that. So with that, I'll move to another feature, which is something we've been working on for a while, and that's coming out this quarter. And that's the concept of auto planning. The idea being, if I have a list of 100 candidate tower sites where I think I can deploy in a new area, what is the optimum site that I should pick to minimize my cost but get the same level of coverage? So in this particular example, we had sites from all over Texas, but for this demo, I've picked a small area in Texas that you see over here with this boundary case. And so if you were to go and look at the auto planning results, you switch into this. So Fort Worth, Dallas area, we've done an auto plan of this area. And let me zoom in a little bit more. And in this particular case, we started looking at the area covered. And as it's loading in, there's still quite a few sites. These are all the candidate sites that you're seeing. And on the right-hand side, it's what we're showing is a list of the final results of the auto planning. What you get is a curve, and it's a Pareto curve. And the idea being, well, if you deploy a different number of sites, you get different levels of coverage. And the number of sites corresponds to roughly how much it costs you to deploy. So you can make trade-offs between how much coverage you want versus how many sites you deploy. So here, if you deploy 2 sites, you get 12.7% coverage. But if you deploy 24 sites, you get 70% coverage. And as you get up into the higher numbers, you start seeing there's diminishing return on adding an incremental site. So what this allows you to do is look at the variety of solutions and allows you to make the trade-off as to how much you want to spend versus the coverage you want to get. And so this is for area coverage. What we're working on this quarter, in addition, is the ability to say you have a list of addresses that you want to be able to cover in this whole area, or a set of data points that represent addresses. We can swap out area for instead giving you coverage as the number of houses instead of as a percentage of the area. So there's some quite sophisticated work that's coming out along these lines. Now, let's say I wanted to take one of these solutions and take a look at that in more detail. So I then go and look at that particular area in a lot more detail, and I can calculate coverage in this area. So I've taken one of the solutions and converted it into a project, and here are all the sites that are associated with the project. I can go in and look at the details of the site as available, the antennas that it was using and its power levels, and then look at the areas around it to see if this actually meets all my needs or not. Following from that, we have a feature that's long been requested, and that's the ability to import in addresses. And so if you were to have a list of addresses, we can do the geo conversion for you to get to a set of lat longs. You can also insert in a set of lat longs. And so you can give us a CSV with a list of 1,000 addresses or more, however many you want. We'll load that up. And in this particular example, we have those addresses as the red dots in the image. And so you can look at that. That's 4351 Little Mississippi Cemetery Road. We give you details associated with that site. We tell you roughly what the spectrum availability is. And we also start telling you, based on Network Planner, whether you have line of sight to the various towers in the area. So that doesn't look like it's got any line of sight. And so let's tweak around to see if there's anything that. Yeah. Let's see if there are any sites that we've loaded that have line of sight coverage. There we go. So here's one which it tells you that this site in yellow has partial line of sight, and the site in red has no line of sight. So if you want to get into this in more detail, we've made it easier for you to access that. So if you just click on the line, it now tells you what may be blocking it. In this particular case, it's a combination. It's the terrain itself. And so we can look at each of the different sites and say, okay, well, in this place, there's some trees partially blocking the line of sight so that it may be okay. And so clicking on any of these sites, we automatically do these computations and tell you more detail. On the right-hand side, we give you some numerical results, which tells you what the best server receive power is, along with all the other information for that particular candidate house location. So along with that, we are having, we're doing work to expand the way we define if a house is covered or not. In this particular example, I take my transmitter and I put a receiver on top of the house. And if there's line of sight or no line of sight, I say the house is covered. But in practice, you may have a house where the north-facing part of the roof is accessible, but the south-facing part is not. Or you may have a situation where some fraction of the backyard may have coverage, but the rest of the house doesn't. So if you want to take a more sophisticated view of whether a house is gets coverage from a particular site, what you may want to do is say, okay, well, I'll take a point that represents the house and take a radius, let's say 50 feet or 100 feet around the house, and calculate throughout that area of the circle, what fraction of that circle will receive coverage or not. And then you may decide, well, if 30% of that circle is accessible, then I'll call that house covered. But if it's anything less than 30, I'll call that house unreachable. And so that allows you to be more sophisticated in how you determine if a house is available or not, rather than just a single point. Because a single point, you may have chosen it on the south-facing part of the roof, and that south-facing part is not accessible, but the north-facing part was, and you don't want to miss those opportunities to provide service to a particular customer that may actually have a house that's accessible. And when you combine that with auto planning, you can introduce that same concept into auto planning, give a list of points, and we automatically go and compute the radius around each of those points and tell you which of the sites are best to cover that set of candidate locations. So there's quite a bit of sophistication coming into the fixed filers features that we have, and in particular around whether a house is covered or not. We also have features that we're working on to make it easier and easier to use the tool, including the part profile, which is something that we've had many customers using it in their production environments. Their customer service agents are using it. And so we're trying to make it as easy as possible for someone to type in an address and immediately understand what's accessible and what's not accessible. So there's a lot of features around part profile that are coming out or have come out in the recent, more recently. Lastly, we've been looking at PALs. Several of you may be interested in purchasing PALs and want to understand the environment for the counties that you're interested in. And we're starting to produce data sets that allow you to go and look at a county and be able to tell at a county level what fraction of the county has 15 channels, 10 channels, 5 channels, and so on, or what fraction of the population of that county has that many channels. So you can use that information to help you decide how much to bid on a PAL channel, or if to bid at all. So that information is coming as well. So with that, I will turn it back to Rob.
Okay, thank you, Matt. That was great. And Matt, just one question we did have from the audience was around what propagation model is being used?
if you're familiar with Asta, that's a very sophisticated propagation model that you have with Atoll. We actually purchased a company that developed Asta, and we've then supercharged it and put it on the cloud. And so it's a ray tracing propagation engine that uses the detailed clutter that we have. And so it isn't an ITM model that WinForum uses. It isn't any of those models that are statistical based. It's actually based on the physical clutter that's in the environment around it. So it does require a lot of computation, but we think it's the best in class propagation model out there.
Okay, great, thank you. And I do see some other questions coming in.
Yeah.
Matt, did you want to expand a little more on that?
Yeah, not to expand on that, but one piece I didn't mention, I know many of you asked about coexistence. We have a series of coexistence features coming out this quarter, including one that if you click on your device, if you pre-register a device, will tell you what the noise environment around that device is going to be. So in addition to whether a channel is available because of incumbents, we're going to start providing you information on what the noise environment is based on our computation of all the other radios that are around you. So that's a feature that's been asked for quite a bit, and that is going to be rolling out this quarter as well.
Great, thank you, Matt. So I do see a few other questions have come in. We're going to hold those to the end. Again, just keep piling on the questions, and we'll address them when we get done. And with that, I'm going to go back to our presentation. So we talked about the network planner. Matt, actually, do you want to just talk a little bit about how some of our customers are using the network planner and the different breadth within their operations?
Yeah, no, that's great. I think, you know, as Rob had mentioned in an earlier slide, there are three main modes of operation. One is you know, you're actually going to have to plan your network. The second is where you have a customer service agent actually take a call, get an address from a potential customer, and try and determine whether to do a truck roll or not. That's probably the most intensive use of the tool today. And the last is folks out in the field deploying radios are actually using the network planner to help them figure out how to align their radios and figure out if they need to move to a different part of the roof. So three modes of operation. It's people doing the network planning and getting their networks into the planner. The sales and service part, where someone calls in, they go and look at the map that I showed earlier. They type in an address into the planner, and we tell you whether there's line of sight and what the power levels are at a particular location. That is probably the most sophisticated feature and the most useful feature for a lot of WISPs, because in the past, their truck rolls have had a high level of failures where you get to a site and you know, it doesn't look like there's enough services available. So then, you know, money is spent on a roll that didn't need to happen, and the customer may not quite be as thrilled with that. So by being able to determine this ahead of time, it saves cost and it improves customer service. We found that to be very useful. The field operations is you're out on the site, and let's say the initial site that you picked didn't quite work out. You can go and use the network planner to figure out if there are alternative candidate locations within that same area. And also, it looks like it's helping with pointing the devices and telling you what azimuth you need to point it back to the different sites that you may have available. So that's something that is starting to be used, and we'll start to roll out features that will help field operations as well. One feature that I didn't quite get into is also we have a line of sight load shed, if you will. So rather than getting it line of sight, RSSI or anything else like that, we actually tell you with yes, no across a whole heat map whether a particular area is accessible by any one of the sites that you've deployed. Okay.
I know, Matt, you touched on a number of some new features that are going to be coming out, like auto planning and coax features. Anything else you want to mention there?
Yeah. So We didn't show this because the features aren't quite out yet, but we've heard from many of you that rather than doing multiple bands where you do 5 gigahertz in one project and 3.5 gigahertz in another, you'd really like to see all the different bands available in a single project. So although you can do all the bands today, many of our customers are confused about that. You can actually do 5 gigahertz in the tool right now. People want to have 3.5 gigahertz, 5 gigahertz, and 2.4 gigahertz all being done within the same project. And so that's something that we're working on that will be launched either late this quarter or sometime in Q3. I've talked about auto planning, a lot of exciting stuff coming along there, particularly with respect to how we define whether a house is available. And the scale of it is quite large. You know, we've had customers or we've done studies on entire states or even entire countries. So there's a lot of sophisticated capability that's coming up there. I mentioned spectrum inquiry and coexistence, where you can find out not just whether a channel is available or not in terms of its power, but what the noise environment would be like for that particular CBSD at that particular location. That's going to be a very useful tool for many. And lastly, PAL support, which is giving you some reports associated with the channel availability across a county. So you don't just have a single number, you have a histogram of what's available in that county by area or by population.
Okay, so the network planner is, it's available now. So you can sign up on our website, g.co/shared spectrum, sign up for an invite. We're expanding what we call early access. We're in the early access period, so we're expanding that now to new customers. It is exclusive to Google SaaS customers in the US. So you can sign up for our SaaS service, check a box that you're interested in the network planner as well, and we'll get an invite out to you as soon as possible. Okay, when it comes to pricing, let's talk about pricing. So SaaS service itself in the fixed wireless world is $2.25 per month per residence. The way we count residents is just a CBSD to CBSD link. So if you set up a Cat B base station, you connect it to 10 CBSDs that are on 10 different houses, and you're providing fixed broadband to those homes. We charge you $2.25 per month times 10, and that's your bill. So then in terms of training and certification, we have a full CPI package at $599, and that gets you registration with WinForm, your digital certificate issuance. You'll do an online proctored exam. That's everything you need to get started installing CBSDs. Or you can also do just the professional training online without the actual registration as a CPI, and that's $399. Now, if you are a WISP member, there's a discount, so you can log into the WISP site and get access to a discount for our CPI training. So we encourage you to get started now. You can sign up at g.co/shared spectrum. You can deploy. Right now, we're in full commercial, the full commercial phase of CBRS. Check the box that you're interested in the network planner, and we'll get you access to that as soon as possible. And that is the end of our presentation. Okay, if there are other questions from the audience, please feel free just to fire them in.
So should I start on some of the questions that I have?
Yeah, actually, I'll take this first one. Right. One good point here, and thank you for pointing this out. If any of you are using Cambium equipment, so there's some vendors where you just get the SaaS service straight from them, and you don't need to sign up on our website. You would just go to that vendor, and like for example with Cambium, and you tell them you want Google SaaS, and they will set you up. Next question. What type of terrain and clutter does Network Planner use? Matt, do you want to address that one?
Sure. So as we've mentioned before, we fly our own aircraft, take our own imagery, and compute all the terrain and clutter information. We have this information at sub-meter resolution nationwide across that 99% that we mentioned earlier, we actually subsample it to 1 meter resolution. So that ultimately the data that we use is characterized at 1 meter resolution at terrain, clutter, and and the clutter is subdivided into buildings versus trees. And that's X, Y, and Z resolution. So if you have a tree and it's got a canopy, we model a canopy on a pixel by pixel basis, not as a single uniform height. And that's at the time that the image was taken. We don't do any forward propagation to calculate, how a tree might have grown. In many areas we take imagery quite often, and so we just update it the next time we take the imagery.
Okay, great. Next question. How does your system work with the other SAS systems?
All the SASs have a way to exchange information nightly that's defined by WinForum. So currently with the other SASs out there, we do a nightly exchange of the locations and some details associated with all the CBSDs, maintaining business privacy. And we use that information to compute all the things that WinForum and the FCC requires to do in order to protect incumbents. In addition, we use that information, at least on our side, not everyone's necessarily doing this, to compute what the noise level would be at a particular location based on our propagation model. And so that is based on the information we receive from the other SASs on a nightly basis. We don't exchange information during the day. It's once a day. So we understand the state of the world as of, let's say, roughly midnight Pacific time.
Okay, next question. Is there an advantage to Google versus others for getting the CPI there? So I assume this question is specifically about CPI training. Certainly we walked through some of the advantages of Google versus others when it comes to a spectrum access system, having access to a product suite, the level of reliability, the geodata and propagation model and compute, where we can give you maximum spectrum. That's a unique asset. But in terms of CPI, is there, do you want to talk about that at all, Matt?
Yeah, let me take a shot at that. So in general, we believe in being very open. Even with our SaaS, we don't lock you in. We think the quality of our product will speak for itself, and that's why people will stay. With the CPI, if you get trained on Google, you can take that and use that CPI certificate on other SaaSs. It isn't specific to Google. There is an advantage to taking it with us in that we make it very easy for you to take, at leisure at your home. We make the process very efficient and very easy. So that would be an advantage to taking it with us, but you're not locked in to using that solely with us. So you're welcome to take it with us and then go and use it with a competitor. There's no issue with that, and we'd encourage you to do that.
Next question is, if we use Cambium for Google SaaS service, will Network Planner be available as a separate product? If so, will that need to be requested through Cambium as well? So the Network Planner, you would have the same access to the Network Planner that you would if you were a Google SaaS customer and just signing up directly on our website. You can absolutely request that through Cambium. They'll direct that to us, and we'll get you access to the product.
Yeah, and just to be, we're offering it right now free because it's in the trial period and we're still developing the product. At some point, there will be a pricing associated with it. Again, our objective is to make deployment for you easy, and so we expect it to be reasonably priced. We don't have that pricing yet. We're still developing the tool. As you can see, every quarter we have a lot of really exciting features coming out. Once that starts to stabilize, we can come out with a pricing. But for now, certainly in all likelihood sometime through the end of the year, it will be available for free.
Yeah, thank you for clarifying that, Matt. That was one point I forgot to mention. Does CPI certification expire?
It does expire and can be revoked. I don't have the time frame for that, but if you give me a few minutes, I will find that out.
5 years, says someone from the audience.
Great.
Okay. Thank you. Okay, good. Well, listen, everyone, thank you so much for coming out and for listening to our presentation and bearing with us through some technical difficulties. We really appreciate the work that you guys are doing on the front lines, getting internet out to people who need it the most. Your work matters more now than, not that it didn't matter before, but it matters even more now during these times. We look forward to hearing from you and working with you in the future. And again, thank you again. Take care. Bye-bye now.
Thank you.